few more additional topics about vectors here. First problem, find the vector with the given magnitude in the same direction as u. I'm going to begin by kind of sketching this out. I'm looking for a vector that has a magnitude of 10. It's in the same direction as this vector u, which is 2, 4. So just kind of a little quick, sketch here. I'm going over to up 4, that's u. And I'm going to figure out what the magnitude of u is going to come out to be. So the magnitude of u, it's just the length of that vector. So Pythagorean theorem will work great, or distance formula. So square root of 2 squared plus 4 squared. All right, that's going to be a square root of 4 plus 16. That's a square root of 20. So 2 square root of 5. That is the magnitude of u. Well, square root of 20, that's pretty close to, or about 4.5 probably, because square root of 16 is 4, square root of 25 is 5. So this is about 4.5 in length. I'm looking for something that's 10 in length. So I want something that's a good bit longer than that, probably twice as long, a little bit off the page there. So definitely I'm going to need to multiply these by something to make that happen. So there's kind of two ways I like to go about it. One, I think is more straightforward but more work. The other one is not too bad. You got to kind of think your way through it, I think, a little bit. Once you understand why it's working, it's pretty straightforward also, I believe. So what I'm going to do to figure this out, I'm going to set up a proportion where I compare the magnitudes of u and v to the x or horizontal components of those vectors. So the magnitude of v is 10, the magnitude of u is 2 square root of 5. And I don't know the horizontal component of v, but I do know the horizontal component of u is 2. So I've got a proportion set up. Now I can cross multiply, that's fine, but I'm going to go ahead and reduce this. I think it's going to make things a little bit easier. So that's going to be 5 over square root of 5 equals x over 2. Just so it's smaller numbers to work with later on. So 10 is going to equal x squared root of 5. And cross multiply. And I'll need to divide off the square root of 5 to get x by itself. But we really don't like to leave those in that form. So I need to rationalize. Multiply by square root of 5 over square root of 5. And we'll end up with 10 square root of 5 over 5. Reduce that down. 2 square root of 5 is x. So a lot of rationalizing, but overall not terrible. We do have the x component. We can basically repeat that process for the y component. So same idea. I know my magnitudes. I don't know the y component of vector v, but I do know the u, or the y component for u is 4. All right. This time maybe I'll just try it without reducing in the beginning, just to show you the difference, but it really doesn't matter. All right, so cross multiply, I want to divide off 2 square root of 5. Do that on both sides. We're going to get 20 over the square root of 5 equals y. We'll go ahead and start rationalizing that. So times square root of 5 over 5 gives me 20 square root of 5 over 5. And I'll reduce, so that becomes 4 square root of 5. And there we go, there's our y component. So our component form for u is 2 square root of 5 for the x, 4 square root of 5 for the y, and now we're done. Now something that I think is a little bit quicker, this is probably the more intuitive way, but I kind of like to do a comparison of the magnitudes in the beginning and kind of go from there. So if I compare v to u, like a ratio, the magnitude of v was 10, the magnitude of u was 2 square root of 5. So that comes up to be 5 over square root of 5, which if we rationalize is 5 square root of 5 over 5, which is just square root of 5. So what I just concluded is that v is square root of 5 times bigger than u. That's the proportion we're looking at here. So what that means is I can just take u, if I want to get v, if I want to get v, I can take u and multiply it by the square root of 5, because it's v is square root of 5 times bigger than u, and I'll be done. Now, that one's maybe a little bit more thinking about why it would work, but if you understand why that's working, I think the process is a little bit quicker, because once I know u, I just need to multiply each component times the square root of 5, and then that's a quick way to get to that final result. Now, either way you go, you'll get to the same result, so it really doesn't matter. Do whatever makes most sense to you. Okay, so now we have a vector in unit vector form, and this one's going to be in the third quadrant because it's left 3, down 6. So I'm going to do a little quick sketch of it. I like to do sketches in the beginning just to get a sense of what I'm looking at. This vector looks something like that. If we're going to find the magnitude, we need to know the length, or the distance, use distance formula to find the length of that. And if we're going to get a direction, you always start from the positive x-axis, just like you did with the unit circle. So I'm looking at an angle that is more than 180, but smaller than 270. So, sort of in that range. If my answer is somewhere there, I should be looking pretty good. I would even go so far as to say if I'm comparing to unit circle, it's pretty close to an angle of maybe 240. So I'm expecting my answer to be somewhere near 240 degrees in the end. All right. So let's go ahead and let's work this out. We've got, first we need to find magnitude, which is basically just distance formula. You went 3 to the left, so you're going to square that, add to it, -6 squared. Really, you can ignore the negatives because you're just going to square them anyway. So square root of 9 plus 36, that's going to be square root of 45. All right, 45 is 9 times 5, so 3 square root of 5 is your overall magnitude. So we're done there. We got to find a direction. But we know we're starting from the positive x-axis, but if we're going to find an angle, then we probably want to use one of our arc functions and maybe draw a triangle. So it's kind of going back to stuff you did back in chapter 4. I'm going to think reference an angle here. So if I draw a triangle like that, and I'm trying to find that angle that's right here between the x-axis and the terminal side, that's the angle I'm looking at. So let me do a little bit bigger diagram of that. So here is vector v, and I'm going down some y amount. Well, let's put these in. We know what these are. We're going down 6. We're going left 3. This is the angle we're looking for. It is important that you get that angle in the right place. If you put it right here, it's going to really throw off your final angle. All right, well, think about problems you've done like that in the past. If you want to find theta, you have a side across from it, you have a side adjacent to it, so tangent's going to be the way to go. Tangent's going to be opposite over adjacent, so reduce that down, you're going to get 2. The tangent of your angle is 2. So take an arc tangent, and make sure you're in degree mode, and you can round on this. We're going to need a calculator. I don't expect you to do this in your head. So we'll make sure we're in degrees. All right, that's good. We want to take an arc tangent of 2. It's 63.4, let's call it that. 63.4. Make sure your answer makes sense. 63.4, that's first quadrant. My angle is in the third quadrant. Okay. So think about kind of how that would play out. 63 degrees is right here. We are going to be a full half circle more than that. Another way to think about it is your reference angle is 63 degrees from the x-axis. This is 180 so far, plus that's 63. So however you go about it, you're adding 63 and 180. So final answer, 243.4 degrees, which is pretty close. I was thinking I was around 240 in the beginning anyway. Sometimes students like to come up with some kind of empirical formula of when to add 180, when to subtract 180, things like that. And if you like doing that, that's absolutely fine. I've honestly found it much easier to just draw a little basic sketch, see about where you are, and just kind of figure out, you need to add 180, subtract 180. I think you're going to have better luck doing that. But if you have trouble with it, let me know, we'll work out something. We're going to wrap up today with finding the component form of a vector with a magnitude of 100 and in the direction of 210 degrees. So again, quick sketch, 210 degrees, that's down here. And the magnitude of this vector is 100. I want the component form, so basically what I'm looking for is how far did I go in the y, how far do I go in the x. Both of these should be negative because we're in the third quadrant. And I'm going to draw my little reference angle there. You can go with the reference angle, you can go with the full angle, it really doesn't matter. If you go with the reference angle of 30 degrees, your answers are all going to be positive, so make sure you correct them. And x should be negative for your final answer, y should be negative for your final answer. I think it's probably easier to this is a unit circle value, so just use 210, and you want to worry about your positives and negatives. It's whatever way you want to go. All right, so what I want to do to figure this out is I've got the hypotenuse. I know the angle I'm looking for. I just need to set up a couple of problems to find the adjacent side and the opposite side. So let's do x first. That's the adjacent side. So that's going to tell me to use cosine. Cosine of 210 degrees will be x over 100. So 100 cosine of 210 is my x value. And you should quickly recall that the cosine of 210 is negative square root of 3 over 2. That should be committed to memory at this point. So negative 50 square root of 3. That's my x value. The component form. Now your y value is pretty similar. Relative to the angle, you've got an opposite and you've got a hypotenuse. So sine of 210 is going to be y over 100. So 100 sine 210 is your y. Sine of 210, that should be something that comes to you pretty quick as well. That's negative 1/2. So negative 50 is my y value. So those are my components, my x and my y. Put them together. Negative 50 square root of 3 is your x. Negative 50 is your y. And that's it.